This lesson reviews the different ways to write a line equation depending on what you are given. And it's not going to go into the different formulas for the different forms of lines. It'll just really more or less talk about the processes. So the first one, and we always start with the slope-intercept form of a line equation, and that is the one that most kids know, y equals mx plus b. There are other forms as well. There's one called point slope. But we're going to talk more about the process than as opposed to comparing two different formulas. So if we are given the slope of a line and the y-intercept, all we have to do is substitute in the slope for m and the y-intercept for b. So, for example, write the equation for the line with slope of 1/2 and a y-intercept of 0.4. All you got to do, you don't even have to solve anything, you just replace the m with 1/2 and the b with 4, and there's your line equation. Now, if you're given a point and a slope, then what you would do is substitute the point and the slope in and solve for b. So basically your point is going to be the x and the y in the formula, and then you're going to substitute in a value for the slope. If I look up here, the point would be an x and a y, and the slopes, you would have values for these three things, and then you're going to solve for b and write the equation at the end. So here's an example. We want a slope of -2, and it passes through this point 1,4. So here's my x value, here's my y value. Substituting into y equals mx plus b, my y value is 4, is equal to, my slope is -2, multiplied by 1 plus b. If you solve that, I add a 2 to both sides, and I end up with b is 6. So my final equation, I'm going to put it over here, is y is equal to, you're going to write everything together. My slope is -2, -2x plus 6. That's how that one turns out. Now, if I have 2 points, what you have to do is first calculate the slope, and then use the process that I described in part B. So you'll be given 2 points, but you need to choose one of them. It doesn't matter which one you choose to solve for b. So here's an example. Write the equation for the line 6, 5, and -3, -1. So 6, 5, and -3, -1. Alright, so given these 2 points, I'm first going to calculate the slope. I have x1 and y1 and x2 and y2. So the slope, give me some more room here. The slope is going to be -1 minus 5 over -3 minus 6. I end up with -6 over -9, and that reduces down to +2/3. So there's my slope. Then I choose one of these points. I'm going to choose this one because they're both positive, and that usually makes it a little bit easier. And I'm going to substitute that into y equals mx plus b. Again, I have an x and a y, so my y value is 5. My slope is 2/3, and I'm going to multiply that by 6, and then I have plus b. So 5, when I multiply 2/3 by 6, I get 4, and b ends up being 1. So my final answer is y is equal to 2/3 x plus 1. So we also need to review special line equations because we're going to be graphing lines and using them. There are 2 special ones. The first one is a horizontal line, y equals b. Okay, it cuts through the y-axis, it is parallel to the x-axis, and it cuts through at whatever y-intercept we have. We also have a vertical line, x is equal to a. It cuts through the x-axis. It is not a function, and it is parallel to the y-axis, perpendicular to the x-axis. X is equal to a, y is equal to b. Those are special line equations. So if I wanted to graph y is equal to -3, let me make that a different color. Let me make that a different, whoops, I need to erase it. Let me make that a different color. We'll make it purple. So you can see it on the graph, y is equal to -3. That means that wherever I am, my y value is -3. So it's going to be a horizontal line. X can be anything you want. Y is equal to -3. If you use an x function, we can graph one of those. We'll make them green. Let's say x is equal to 2. That means y can be anything you want. X is going to be always +2. It's very important you understand those horizontal and vertical lines. We can also graph inequalities with these special lines. If I want to graph x is greater than or equal to -3, first of all, we know we want a solid line because it's greater than or equal to, and in this case, if I want values greater than 3, I'm going to shade to the right. So x is greater than or equal to 3. I put in my x is equal to 3. It's a solid line, and then I shade to the right. An example of a y or a horizontal line, if I want to graph y is less than 2, that's going to be dashed because it's just less than, and I'm going to shade down. It's going to be below the line because it's values that are less than 2. So I put in my dashed line, and this one would be shaded underneath it, all the values that are less than 2. And we can really graph any inequality. It doesn't have to be the special line. So if I look at this one, y is less than or equal to -1/2 x plus 5, I'm going to graph the standard line, and then I'm going to shade appropriately or accordingly. This symbol, since it's less than or equal to, that means it's going to be a solid line. And I want to shade below because it's less than those y values. So if I come over to my graph and I go up 5, there's my y-intercept. My slope is -1/2, so I go down 1 to the right 2, down 1 to the right 2, or up 1 to the left 2. It's going to be a solid line because it's less than or equal to. And then I need to shade where my y values are going to be less than. You can also use a test point. If you use 0, 0, you should get a true statement. 0 is less than or equal to 5, so that's the way you're going to shade. So we'll graph a system of inequalities, and then we will practice some more of this in class. But we'll do this one either. If I have y is greater than x, and the second inequality is x is less than or equal to -2. Y is greater than x. My slope is going to be 1, and my y-intercept is 0. This one's going to be dashed, and since it's greater than, it's going to be shaded above the line on the roof. So I have an intercept at 0. My slope is 1/1, so he's going to be dashed up 1 to the right 1 or down 1 to the left 1. And since I want my y values greater, you shade above the line. If I'm sitting on this line, I want y values greater than where I am. So if you look in the y direction, everything above is going to be greater than. So x is less than or -2, less than or equal to -2. That's going to be a solid line. And the x is the vertical line, so I don't have above or below. I have left or right. I'm going to shade to the left because those values are going to be less than -2. So he's a solid line where x is -2, and I shade to the left. So we'll be doing a lot of practice in class with this, just so you can remember what this is all about, because it's been a while since you've graphed linear functions.